This screencast shows how to solve rational equations. And a rational equation might look something like the equation I'm writing on the screen, where I have rational expressions in the equation. In this case, I have 2x minus 1 over x equals 3 over x plus 2. And there's a couple of different schools of thought on how to solve them. The method I prefer happens to involve finding the common denominators and then multiplying both sides by the common denominator so we no longer have a fraction. In this case, I have x and x plus 2 as my denominators. They don't really share anything in common as far as common factors, so I am going to multiply both sides by x times quantity x plus 2. And they're both in the numerator because we're multiplying. And I'm looking to see what can I reduce that's in both numerator and denominator. I have an x in both numerator and denominator on the left side. I have an x plus 2 in numerator and denominator on the right side. So when we multiply, we have 2x minus 1, that was already there, times x plus 2, is equal to 3 times x. Doing the multiplication, we get 2x squared plus 4x minus x minus 2 is equal to 3x. Combining like terms, 2x squared plus 3x minus 2 equals 3x. Because this is quadratic, since I have 2x squared, I'm going to get it equal to 0 and solve. We're going to subtract 3x from each side. So I have 2x squared minus 2 equals 0. The first thing I notice is that both terms have 2 in them. So if I factor out that 2, we have 2 times the quantity x minus 1 equals 0. I can factor x squared minus 1, that's x plus 1, and x minus 1. If I set 2 equal to 0, it doesn't make sense. Set the x plus 1 equal to 0, set the x minus 1 equal to 0, subtract 1 from each side, and x equals negative 1, or in the second part, I'm going to add 1 to each side, x equals positive 1. Now, before I can say I'm done, I need to make sure my answers make sense. In a rational equation, that means I am not dividing by 0. If I substitute negative 1 into each denominator, I do not end up with 0, so it's okay. I get 1 and 1, so that's all right. If I substitute in 1, we get 1 in one denominator, 3 in the other. Again, not 0, so they're good. So those are my two answers. Let's say I have x minus 4 over x plus 2 plus 2 over x minus 2 is equal to 17 over x squared minus 4. Now in this case, not all my denominators are factored. I need to factor the x squared minus 4 into x plus 2 times x minus 2. And I can see that my common denominator has x plus 2 in it and has x minus 2 in it. So we're going to multiply everything by x plus 2 times x minus 2. And you'll notice what I'm actually doing here is I'm writing that by each part. Technically, I am distributing that x plus 2, x minus 2 to each side. And since I like to be able to reduce, and we usually like to cross them out, I like to write them by each fraction, plus that helps me to remember to distribute. In the first fraction, I can reduce the x plus 2's. In the second fraction, I can reduce the x minus 2's. In the fraction on the right side, I can reduce the x plus 2 and the x minus 2. So what do we have left? We have x minus 2 times x minus 4 plus 2 times x plus 2 is equal to 17. Doing some multiplication, x squared minus 4x minus 2x plus 8 plus 2x plus 4 equals 17. Collecting my like terms, I have x squared. I have negative 6x plus 2x and negative 4x plus 12 equals 17. Need it equal to 0 because it's quadratic, so I'm going to subtract 17 from each side, and I get x squared minus 4x minus 5 equals 0. This factors into x minus 5 times x plus 1 equals 0. Set each individual factor equal to 0. X minus 5 equals 0. Add 5 to each side to find out that x equals 5. We also have x plus 1 equals 0. Subtract 1 from each side, and we find out that x equals negative 1. As we're checking here, if I substitute in 5, no zeros in denominators, so that's good. We have negative 1, no zeros in denominators, that's good. So both answers in this case are good. Let's look at one more example. This time I have x over x plus 2 minus 8 over x squared minus 4 equals 2 over x minus 2. Once again, I have a denominator not factored. My middle denominator should become x minus 2, or x plus 2, x minus 2. And that happens to be my common denominator. So once again, we're multiplying everything by x plus 2, x minus 2. And you can see I'm writing that in blue by each term. Again, that helps me to reduce and helps me to remember to distribute to all terms. X plus 2 in the first fraction reduces. X plus 2 and x minus 2 reduces in the second fraction. And in the third fraction, the x minus 2 reduces. So we have x times the quantity x minus 2 minus 8 equals 2 times the quantity x plus 2. X squared minus 2x minus 8 equals 2x plus 4. Quadratic once again. Subtract 2x from each side. Subtract 4 from each side. And that gives me x squared minus 4x minus 12 equals 0. Factoring, x plus 2 times x minus 6 is equal to 0. X plus 2 equals 0. Subtract 2 from each side, and we get x equals negative 2. Set x minus 6 equals to 0, add 6 to each side, or x equals 6. Now this time when I substitute in negative 2 for x, in this very first denominator, I get 0. So this answer doesn't work. Usually I put a nice little light X through it. However, x equals 6 is fine. So this time I only have one answer. Now, when you have an answer that doesn't work, that's called an extraneous solution, which means, hey, I got an answer, but it's extra. It doesn't fit my domain values. So this time my only answer is x equals 6. And that concludes this screen class on solving rational expressions.